So plastics and polymers, well, a little bit of background information about this topic is that many of the carbon compounds that are present in living organisms, such as carbohydrates, proteins, and DNA molecules, we all know those are all examples of biological organic compounds, or also otherwise known as macromolecules. Okay, we know what the prefix micro means, of course. Micro meaning very small, macro meaning quite large. Okay, macromolecules, which is also known as polymers. This is a very theory lesson or session today. Please have your pens, notebooks, piece of paper, all handy. All right. An example of a natural polymer is rubber. Right? Rubber, which is extracted from rubber trees. Okay. In the past century, scientists have also prepared large variety of synthetic polymers. In other words, if anything is synthetic, it's not natural. Of course, it is man-made. Many of these substances, they form part of the plastics industry, and they are manufactured from carbon compounds of fossil fuels. So, plastic is an example of a synthetic polymer. It's also known as synthetic polymer. All right, terminology. And the first thing we're going to look at again is macromolecules. Okay, the definition for that, okay, this is definitely examinable, right? These are molecules consisting of a large number of atoms, okay? Sometimes hundreds or even thousands, all right, of atoms can bond together to form macromolecules, okay? Second piece of terminology is polymers, okay? Polymers, right, they are also large molecules, right? They are large molecules composed of smaller monomer or monomer. Okay, we'll discuss that in a second. All right, units covalently bonded to each other in a repeating pattern. So like ethene bonded to each other like 3 or 4 times. Okay, that's what a polymer is. And then the last one is monomer, or what are monomers? All right. Monomers, they are small organic molecules. They're small organic molecules that can be similar to the definition on top of it, that can be covalently bonded to each other in a repeating pattern. Does everybody have that? That's more or less straight. Well, kind of works. So once everybody has that down, the next part is when a polymer consists of one kind of monomer. Okay, so if there's only one kind of monomer, okay, for example, ethene, that's maybe bonded to each other multiple times, okay, but that is the main, or that is the only monomer that exists, even if it's repeated 3 times. If it's ethene repeated 3 times, the monomer is definitely still ethene. All right. Then there's a name given to this kind. If it's only one kind of monomer, it's called a homopolymer. If there's more than one, okay, of different kinds. So if, for example, if I must draw it in blocks, so if that's one bonded to, well, that's another one, all right, and then got that one again, and then there's that one. You guys catch my drift. If there's more than one type of monomer, then it's called a copolymer. So types of polymers that do exist. Types of polymers that do exist. You have the first one, which is thermoplastic, okay? And then you have another one, and I'll do them alongside each other, which is thermosetting. Okay, so like I said, the 2 different types, okay? So under the thermoplastic polymer, all right, these are the polymers. They do consist of long, thin chains, and they are braided together.
So they're like intertwined.
You call it that, yes, yes. All right, like braids of hair. All right, and the forces that exist in between these ones they are van der Waals forces, but they're weak. I'm going to use VDW, weak van der Waals forces that exist between these chains in the thermoplastic polymers. All right. And these chains, they can be easily moved, or they can easily move over each other when heated or stretched. All right. Then we're going to move on to thermosetting polymers. I'm going to do it on this side, obviously. With the thermosetting polymers, these plastics, they do contain, so for thermosetting polymers, these do contain a network of large molecules with cross-linking between them. In other words, they crisscross. Cross-linking between them. There's one more point. They cannot easily move over each other. All right, cool. I'm going to give you some general properties of each, okay, and I'm going to denote them by using like a. So I'm just going to give a couple of general properties. I'm not going to share too much because these are all for like general knowledge purposes. The thermoplastic polymers, they can be softened, can also be reshaped. Okay, we can change the shape of these things. They can also be hardened, all right, repeatedly by heating and cooling. So to make soft or to reshape, you would obviously use heat, and if you want to make it hard or harden it again, change it back to a solid phase, you would obviously cool it down. Then for the thermosetting polymer, these compounds, they set into hard, rigid substances and they do not soften when heated, okay? So when a thermosetting polymer is heated, it does not soften. It cannot be made soft, all right? They would break rather than be reshaped. Right, the next bit of theory is we're going to have a look at the preparation of a polymer now, right? The preparation of a polymer, okay? There's a number of ways that we obviously can do this, all right? There's a term called polymerization. Polymerization, this is a chemical reaction in which monomer molecules join to form a polymer, okay? That is called polymerization. Any questions on that one? I think not. All right. All right. Just to give a little bit of an explanation, though, this process, all right, can take place by way of two different ways, which we've learned in organic chemistry already, namely addition reaction. All right, we know the different types of addition reactions, and or elimination reactions. Okay, so a large number of monomers can attach to each other by addition to form long chains. So the last part is obviously the most important part, which is like a large number of monomers, all right? They can attach to each other, all right, by addition. All right, cool. So I want to go over the addition polymers quickly. There's two terms here quickly for everybody. Addition polymerization, and there's also an addition polymer. They are two different terms. So the first one that I'm going to go through is addition polymerization. And what this term means, first of all, it's a reaction, okay, similar to the ones I've just mentioned, all right, in which small molecules, they join to form very large molecules, with larger molecules by joining, or sorry, by the addition of double bonds. Then the addition polymer is a polymer formed when, and this is the way I'm just going to say it now, monomers, okay, usually containing a double bond, by the way, combined through an addition reaction. Okay, so the first one, just to go over again, addition polymerization. It's a reaction in which small molecules join to form very large molecules by the addition of double bonds. But an addition polymer is a polymer formed when monomers, usually containing a double bond, combine through an addition reaction. And we'll have a look at the difference shortly. So polythene, all right. Polythene, the type, obviously I gave you two different types. I gave you thermoplastic, and I gave you thermosetting polythene to start off. Maybe it is a thermoplastic polymer. All right, but if you
How do
look,
you know that?
I know that because of the definition of what a thermoplastic polymer is, number one. Also, I know what polythene is made up of.
If you draw it out, can you like tell?
Yeah, I'm going to draw it out for you.
Okay.
Okay, cool. What was I saying? Great. So, polythene. Can we all see this part here? So it's kind of hidden in the name of what polythene is made up of. So obviously we know that a polymer consists of multiple. Thank you, Christian. Yes, consists of monomers. So polythene is a polymer of ethene. Great. Now, what I want to say about ethene quickly is that ethene is what is known as a simple monomer. So that's simple monomer. We all know that. Polythene, yes, which Jess has mentioned faithfully. Thank you. Is short for obviously polyethene. All right. There's even a longer name, which I'm not going to get into now because it's not necessary. All right. So now polythene is formed when ethene molecules attach to one another. Okay. So when ethene molecules, all right, when they attach to one another, okay, this is the example of the reaction of polymerization. All right. So literally like thousands of units of ethene may attach to each other within 1 second. All right. But for exam purposes, for this, and this is purely for exam purposes, all right, you only need to know and write the equation for the addition polymerization reaction of ethene. Okay. So for example, if I must write the equation, I'm going to the structural formula in the equation. I'm going to obviously have, there we go. I'm going to omit the hydrogens for now, plus, all right, cool. I'm just going to leave it at 3 for now in terms of space. Catch the drift. That will obviously give you, when all of these add to each other, the double bonds, they do break up, okay? Okay, they break up into single chains, 2, 4, 5, 6, bonded to each other, and that would be your polyethene, okay, because these are ethene polymers, or monomers, sorry, ethene monomers, and over here you have your polythene, or your polyethene. And that is all you need to know for this thing with regards to exam purposes. That's the structural formula equation, and that's what you will be required to know for your exam at the end of the year. Going to do another one, but the other one that we're going to do now is what happens if we still have a ethene monomer, but we have a halogen attached to it instead of a hydrogen. I'm going to show that the same thing still occurs, but I'll show that to you in a second. I'll give you guys a couple of seconds just to get all of that down. All right, cool. So what happens if we have chloroethene monomers here? So like I've already started drawing. All right, so if you just add another one to this one, let's make that the Cl one. And there we go. Now what happens now? Okay, here I've got my chloroethene. All right, and so the same thing here does occur. Okay, still a straight chain molecule that forms, or a ethene. Not an ethene, a polymer occurs still with still with 6 carbons, as we have on the left, which we will have on the right as well. But it does have a different name. And the reason, I'm just going to finish drawing it quickly. Okay, that's the chloro there, which matches that one, of course. Which matches that one. And which matches that one. and the rest are all hydrogens. Do I need to fill them out? Right, so obviously this has a name, all right? It has a name. The name given to this, all right, obviously has the prefix, it is prefix, right? Yes, the prefix poly in front of it, okay? But it changes to polyvinyl or polyvinyl chloride polymer. So when the polymer obviously is formed, it becomes, instead of saying polychloroethene polymer, it takes this name because naming it, it sounds better saying polyvinyl chloride than polychloroethane. Also, the person that invented the subject thinks or thought. And the also reason why it takes that name, because it's also, have you heard of PVC, like PVC pipe?
Oh yeah.
Yeah, so PVC. Um, PVC is also, besides PVC pipe, you can also get drip feed bags for some the bags that make certain animal feed and stuff like that. Or for dripping, if you want to make obviously drip free pipes. If you have PVC gutters, some people use PVC gutters as well nowadays than the olden type gutters. All right. Let's see what we got here. Define the terms monomers, and then 1.2. All right. I also want you to define the term polymers because they obviously are different. And for 1.2, I just would like everyone, obviously on their own pages, to draw the structural formula for, let me see, the addition, polymerization. For 1.2.1, polythene or polyethene. So you can see there's ethene in this one. Oh, gosh. And then 1.2.2, the polyvinyl chloride, which is on the board, which I will erase, but yeah, you get the point. All right. That's the momentary exercise. I will give you up until 22, so 6:40. All right, so we've had a time now just to go through the answers of this quickly. So the first question, I'm just going to do the first two answers just here on top. Okay, these are your theoretical answers, and these are your short questions in the exam, in the test. Define the term monomers. So for 1.1, the term monomers, they are small repeating units. Okay, small repeating units or molecules. Okay, obviously we learned them as molecules, repeating molecules. All right, they're small repeating molecules from which polymers are composed. Okay, anything along those lines. If you said, for example, that they are small repeating molecules and polymers are composed of them, or if you said polymers are composed of repeating small molecules, anything along those lines would have still got you the mark for what the definition of monomers are. And if you gave an example there, that's always encouraging. So now the second one, what is the definition or the term polymers? And the definition for this is, first of all, it's a they are large or are very large organic compounds or organic molecules, rather, that consist of smaller, but also just not smaller, but smaller identical repeating units or repeating molecules. I'm going to use molecules in this one. Last part, that are bound together to form long chains. Okay, anything along those lines would have obviously also got you the mark. So well done if you got those two correct.